Do we have mobile developers in the room? Yay, maybe half of them. Cool. Thank you all for coming here. GraphQL was made for mobile apps, so we're going to talk mobile and architecture during the next 30 minutes. My name is Martin. I've been doing Android apps for a very, very long time. I started with Cupcake in 2008 on the HTC G1. You know, these nice little phones with a slider and a small ball with your cursor on it. Today I work at Apollo, where one of my main duties is to maintain Apollo Kotlin, a type-safe GraphQL client for Android, but also for Kotlin multi-platform, so you can use it for iOS if you want to, or WebAssembly. And I don't like talking too much about architecture, because it's very opinionated. Like, people have like their own framework, their own preferred architecture, then sometimes like it goes into frustrating discussions where people talk, you know, past each other. Which is why today I'm going to make a talk about architecture. And hopefully it will go well. Why today? Because it's the 10 years of GraphQL. We've been doing GraphQL on mobile for 10 years. So I think it's a good time to reflect on what we've been doing. And also because I'm talking with a lot of web developers and a lot of mobile developers, and sometimes looks like there's a small disconnect there. So it's good that we have half and half here today. Like, we have a bit of a small mix of developers, because I hope we can learn from each other. If I zoom out a little bit, at the very beginning was MVC. We all know model view controller. Like, if I zoom out of all the architecture that have been happening in the last 10 years, or actually more like 40 years for MVC. There's been MVP, model view presenter. There is MVI, model view intent. Don't ask me exactly what it is, but it's a thing. MVVM, model view view model. And then you can throw in a pinch of like clean or Viper or hexagonal architecture, which is like, at this point, my brain usually phases out. And I'm like, yeah, just do model view, whatever works for you. This is perfectly fine. A few years back, Google introduced Jetpack Compose. It's a complete shift into how people build Android apps. It was built from the ground up based on all the experience the team had working on Android. Well, you know the drill. It's a declarative framework. It's, well, a single source of truth, unidirectional data flow. It is very strongly inspired by React. Actually, some of the Compose team members are former React core members, like Jim Sproor, if you know him. So yeah, it's no secret. It's very, very similar. And it comes with a lot of recommendations, like a lot. You can go to Google webpage and you will have, I think I have counted 29 recommendations. One of the big ones is you should use a view model. View model is where you store everything related to your screen. And you have sub-recommendation, but at least it gives you a framework, right? This is how you build Android apps. So in practice, if we were to build, like, I don't know, for an example, an app for GraphQL conf, where you would display a list of sessions, you would typically do something like this. You write your GraphQL, you query fields in your session, like title, start time, end time, things like this. You take Apollo Kotlin, you generate type-safe Kotlin models from your GraphQL. Whoops, a little bit too fast. You expose that through a data source. Most of the time, this is where you do the testing. So the data source, you can have the real one for the network, and then you make a separate one for your test using fake data that you get from some JSON or something like this. You expose everything in a GraphQL repository, which is where you usually do the persistence. You might do this using Room, which is the standard way to do SQL on Android. So it's a SQL-like implementation for Kotlin. Then you have a domain layer, which is optional, and you go to your UI layer where you have your sacred view model that exposes UI models to your actual views or composable, like we call them. If you are not a mobile developer, at this point, you're probably like, what? Like, it's a lot of boxes. Why do we need all those boxes? And if you've been using Apollo Client, things are a lot simpler. Like you have just one file. You put your fragment at the beginning of your file. On a session object here, you query the title, start, and list of speakers, everything. You register it to your fragment registry, and then you can just use it in your React component. So it's very easy. Well, if you've been to Janet talk earlier, you would also learn that fragment collocation is very important because you have a close relationship between the place where you define your data and the place where you use it. And it has a bunch of benefits, like avoiding overfetching, for an example. So why? Why do we, mobile developers, like to go into all these layers and everything? So I'm going to go through a few possible explanations. Maybe you have yours. I'm very curious to hear them. And the first one that I heard is we need view models and we need different layers to handle Android apps lifecycle. An Android app can be killed at any time when you receive a phone call, for an example, and you are receiving or typing a message. You don't want to lose all that process. So, or even if you rotate the screen, like on Android, if you rotate the screen by default, it kills your app and then recreates it. So by using a view model, you can save some state in your view model, and yeah, you don't have to do your network call again when you restore the app. I'm not buying this too much because, well, first of all, for mobile phones have gigabytes of RAM now, so you can probably get a phone call and write a message at the same time. And at worst case, you have a GraphQL normalized cache, which allows you to persist your data. So if everything is in your GraphQL cache, well, it's like your view model. This is a good place to put all your data. So I'm not buying this one. Another one is, well, we can use all these different layers for testing, and then we can add a fake repository, we can add a fake data source, and we can have fake network models, and you end up with a lot of testing at every layer. But if you have a normalized cache, you can also just make one big fake GraphQL service, and it's working the same. Like on Apollo Kotlin, we have Apollo Kotlin Faker, for an example. You give it your schema, and it's going to generate mock data, randomized mock data for you. So not buying this one. Another interesting one is, yeah, I like to separate my data models from my UI models, because then I can change all my backend and I can reuse all my UI. Has this ever happened to someone here? Yeah, I don't know. Usually it's the opposite. Like you don't want to change the backend at all because like you have apps from 10 years old that were not updated and you cannot change your backend. So I don't know. Maybe some people do change their backend very often, but I give it benefit of the doubt. Possible solution, separate concern. This is actually a good one. If you have a lot of business logic, you don't want to clutter your UI views with your business logic. So you put that in a separate layer. But I'm also going to argue that if you have a lot of business logic, you can move it to the backend and, well, not have all your clients do the same thing multiple times. Like you won't have the same implementation of your business logic for iOS, Android, and web, and then have subtle bugs in every client. So yeah, maybe if you have something that needs to lie on the client, it's a good reason. Well, I think the main reason is just habits. Habits die hard. Like we've been doing this for 40, 50 years, something like this. We know REST, we know SQL, it's working well. Google tells us to do view models. Why should we do otherwise? And actually, we, as a GraphQL community, we also tell you to do so. If you take a look at Janet's session description, yeah, it's pretty clear. Like if you go to the GraphQL education documentation and all these pages, we tell you to use fragments for reuse and just query all the fields in your entity, store that in SQL, and some people may understand it like this. And, well, it's been 10 years, so I think it's time that maybe, I don't know, that's a question mark, but maybe we should start to change our habits. Looks like Janet is on board. It took me some time, but I am on board now. And we are not the first one. If you remember, I talked about Jim Sproch earlier, like Jetpack Compose, one of the Jetpack Compose creator, and he has some strong opinions about view models. He says, and I'm quoting, it's a clutch for Android. I see no reason to proliferate bad patterns. So that settles it a little bit. And he goes on to say, you should take, he says a lot of good things about GraphQL, actually. It's working well for Meta. You have a normalized cache that is doing all your persistence and everything. And it's also making sure that you have consistent data across all your app, which is a very good thing. So let's see how we could do this in our Android apps. We would need two things. First one is we would need to remove the view models and all the clutch, all the different boxes. How would we do this? Well, it's easy. We remove everything. So we remove the UI models. We remove the intermediate things that don't really add value. For the persistent, we move everything into our GraphQL normalized cache because it can also be persistent. And yeah, it's a bit better. It's cleaner. It's not 100% finished yet. Like, we need a second thing. Right now, there is still GraphQL on one side and UI views on the other side. We don't have fragment collocation 100%. So let's collocate our fragments. Let's make some room on the right for our fragments, and let's move them like this. This way they can like live happily ever after. So we took a look at this in Apollo Kotlin and thought about how to solve this for our apps. And we ended up with two new repositories that we are introducing today, actually, last week, but actually before. These are separate repositories for now because we will be able to iterate faster on this, but the aim is to merge them eventually. First one is Apollo Kotlin Compose, which is actually a big departure from Apollo Kotlin, what we used to do, because it's the first time we actually bring some UI elements and some UI logic into Apollo Kotlin. So for now, like, we have a bunch of issues on the repo where people are asking, like, how should I do my UI with Apollo Kotlin? And the response has always been, well, we are network agnostic, like, do your thing, MV whatever you want, but it's not our problem. Now we have a solution. You can use Apollo Kotlin Compose. It brings use query. The naming is coming from the web, actually. That allows you to just call into a composable and call your GraphQL normalized cache directly into your UI tree. So that's for the first part of the equation. And the second part is fragment collocation. So right now you have your GraphQL queries in GraphQL files. And what we did is create a GraphQL Kotlin compiler to extract those queries from Kotlin files, so you would have them as string literals, and generate intermediate representations that would be directly embedded inside your apps. So you have the repos there, give them a star, but instead of talking about them, I'm just going to demo them now. And yeah, I have what? Well, I have time. We're going to build a GraphQL conf app using Apollo Kotlin Compose and the Kotlin compiler. All right. So let's take our favorite ID. Is it big enough? A bit more? Like this? All good? All right, so if you're not familiar with IntelliJ, this is what I spent most of my time in. It's a typical Android project here. You have a bunch of files, Kotlin files here. These are the two important ones. Main activity is the entry point for your Android application. And this is where we are going to add our stuff. But before we add our UI, we need to do a little bit of Gradle configuration, as always. So let's go to our build.gradle file and add our compiler plugin. So let's do this. I'm cheating a little bit with templates. Yes. So it's a Gradle plugin that's going to add the Kotlin compiler plugin. So it's two plugins in one. For the plugin, we also need a runtime. So we need something like this. And we are also going to need the Compose runtime. There's a little bit of magic here, but if you click here, yeah, it's going to take you here. So these are where all those things are defined. As you can see, it's a lot of snapshot version, which means it's very stable, right? So I think we are good here. I'm going to sync my project. If I go here, and while it's building, yeah, all good. I need to give it a little bit of configuration here. So I need to configure my compiler plugin with a schema. I need to give it a schema. I need to enable the compatibility mode with Apollo Client so that it generates code that works with Apollo Client, and configure my Scala adapters. So the GraphQL conf schema uses custom scalars for dates and IDs. I mean, ID is not a custom scalar, but we need to map that to actual Kotlin types. So here it's Kotlin X date time, local date time, and then we map ID to string. I think we're good. Let's import that once again. Go to the main activity file here. So it's empty. It's a single activity, a simple activity for now, sorry. Just a title and a session list. What I'm going to do is create a builder for my Apollo client here. I use the endpoint of the GraphQL conf GraphQL API and wrap all my app into that using Apollo client provider. Yep, like this. Let's wrap everything. This way, whenever I write a new composable function, I get automatic access to my client. If I were writing tests, for an example, I could substitute this Apollo client with another one that is using a fake service. Let's try to run this to make sure I did not forget anything. Okay, so it's all good, but we don't have much to display. So let's go into the session list here and let's try to display something. So we are going to do a query. And the way the Kotlin compiler works is it needs an entry point. So it needs one class that is just going to identify your query. So I'm just creating a getSession class, and then I'm going to annotate it with @query and give it my full query like this. So it queries the session and the title of each session. As you can see, the ID automatically added here inlays, ints, I think that's the name of them. Ints, yeah. It says super type added by a Kotlin compiler plugin. So what this is making under the hood is it's parsing the query here and generating the types, except it's not code like it used to be, it's just intermediate representation. Let's use this. So let's do it like this. Let's call into useQuery and let's call get sessions. Yes. All right, so now I have my state and I can decide what to do depending what I receive. So I read the value of my state. If I don't have anything, I'm just going to display a loading screen. Oops, so if I have an error, I'm just going to display a generic error message. And if I have a success, I'm going to display something. So I'm going to display the list of all the titles. And I'm going to use a text composable and just display. You see I have autocomplete here, which means the ID recognized as a query. If I change it here, if I maybe add the start time here, now I can query the start time, and I can also query the title. But let's keep it with title. All right, let's hit play. Let's build all the things. And we have all the titles, so hey. In just one file, this is what's important. We have just one file with everything. But now let's take it one step further and make it look actually a bit better with more information about our session. So we are going to define a fragment. So same thing for fragment, we need an entry class like this. And instead of using @query like here, well, this is small actually. Could you see that? Yeah.
Yeah, if you can click or command plus it.
Is it good?
Yeah, that's better.
Sorry about this. Yeah, instead of having query here, we have fragment now. But it's the same thing. It's really the same thing, and same. It's going to generate types for us. So I create a new composable function. This is how we do it on Android. It's not components, it's composables. And let's call it session card. And this is going to take a session that is going to be a session details dot data. Here, this is where I'm going to cheat a little bit. I'm going to import a huge quantity of code all at once, so please stick with me. This is just your usual Jetpack Compose stuff, like your display, the font size, and a bunch of stuff. This is not a talk about Compose, but well, this is basically everything to make it look good. What else do we need? So yeah, I define my fragment here. I need to use my fragment. So let's use my fragment here. So instead of title, I'm going to query the session details fragment. And let's use it here instead of having a single text. I'm going to do a lazy colon. Oh, I can type this. I can type this. Modifier. I'm going to give it some padding. Horizontally. Like this, and it's going to use my items. So where do I have my items? It's in data. You can see it's all type-safe, and it's not null by default. So I don't have to check for all the nulls. Like this. And let's call the session card with the fragment results. All right. Let's hit play once again, and hopefully we have something looking good. Yay! So as you can see, there are still some small things. The IDE is a bit confused what's happening. This is still under works, which gives me my perfect transition with my last slide. Closing out here. Yeah, so this is building fine, but the IDE still is a bit confused because it's not evaluated in the same order. So sometimes you will see some red underline still. This is still ongoing. But please use it and let us know all the quirks you bump into. And a couple of final thoughts is, I think simple is better than complex. So if we can get rid of intermediate layer, we should do it, probably should do it. But in all cases, I'm very eager to continue the discussion about architecture and hopefully not have a frustrating discussion, but we can all share about it. Well, with that, thank you very much. And I think we have time for questions.
I
Yes.
Did you get the IDE support for free from the So that it just because at one point Kotlin compiler was not like adding IDE support for.
So this is the whole key to stuff. If you've been following, like the Kotlin team rewrote like the whole compiler to split it between the front end and the back end. So we now have two intermediate representation in Kotlin. Front end IR, which is basically only for the IDE. I mean, the backend is going to use it, but you can just use just front-end IR in the IDE, and it's very lightweight. So it's evaluating all the time. And this is why it was red at the end, because as soon as you type something, it runs the compiler, and it computes all these front-end IR types. Instead of making a global pass on them, it's very local. And it does not contain any of the body or the implementation or something like this. It's just the names, basically. And if you want to have support from the IDE, it's brand new, actually. You need to opt into that. Like, there's a specific registry key. Like, it's not even in the JetBrains. Yeah, it's not in the IntelliJ settings. Forgot what's the name of the settings of the registry key, but you go into help, and then you go into edit registry keys, and then you type your thing and you say true, because by default it's doing it, but only for the built-in compiler plugins like serialization, like Compose, obviously. But if you want to do it for third-party plugins, you need to opt into that. But it's really cool. Like you get it for free. Yeah. Yeah. Yeah, no, it's really cool. The future is bright.
Are the models being generated, the class being generated, identical to the old Apollo models, or have you changed or rather, what I'm really interested in is what's the inheritance model? Like, when you have a fragment spread, does the parent inherit or not?
That's a good one. When we wrote Apollo Kotlin 3, like, we wanted to generate fragments as interfaces. So we ended up with two codegen options in Apollo Kotlin. We have one that we call response-based, because it's going to generate fragments as interfaces, and it's going to match exactly the size of your response, which is really good because it gives you a lot of type information. But it's also really bad because it gives you very, very deep models. And if you do a lot of very, very deep fragments, I don't know if you've been to the Netflix talk before, but they have these very deep queries with a lot of fragments. And you can do stuff that blows up your codegen very easily. And so it blows up exponentially. So you can write a, 20 lines long query that generates 20,000 lines of Kotlin code, which is not great. So the default codegen we have right now in Apollo Kotlin is what we call operation-based. So basically, each fragment has its own class, but there's no inheritance, really. So it loses some kind of type information. What I'm hoping, this new codegen, like with the compiler plugin, it's basically operation-based, which means fragments are generated as classes, which is good because you have also data masking out of the box. What I'm hoping is we can do something a little bit more in between, because we have more locality. We don't have to consider the query as a wall. We can...
But the inline fragments are
Exactly. Like, if you have inline fragments, we could probably generate that as a sealed class hierarchy, which work really well in Kotlin, because then you have exhaustive type checks and so on. So this is the hope that we can do this year.
Sorry, are there also any plans to add this to Apollo iOS too?
I don't know if you can do compiler plugins on Swift. Maybe with macros, it's probably going to look different, but I guess yes.
But this is on the horizon to the implementation of this for iOS as well.
I can talk for the iOS team.
They're not here, so
let's call them.
Can we talk about that?
Sure, sure.
That'll be interesting.
Yeah, definitely.
And if you go back in your demonstration, you had the fragment and the query in the same file.
Yes.
Is that necessary to make it work, or is that just for the?
So yeah, right now the thing is the Kotlin compiler is very adamant about making things locally. So if you have everything in the same time, it's all evaluated at the same time. If I move the fragment out, like in some cases, and to be honest, I made the last commit on this like 2 days ago, like just before taking the train. So the demo is working, but it's still pretty much experimental. And if you move it across a lot of files, the order in which the fragments are evaluated becomes important because we need the fragments to be registered before we compute the query. And so the order in which the files are computed starts to matter, which means, I don't know, like I'm hoping to discuss this with the Kotlin team, see if we can do something about this. Maybe we will have to, hook into the symbols resolution or something like this. But if you have a lot of different fragments, I mean, the queries and the fragments right now, it's better if they are in the same file. Let's put it like this.
Thank you.
Yeah, sure. Yep.
What if your data is more reactive, like a user logs in and you need to... So this works great for static data.
Mm-hmm.
But what if something changes and you need to refetch data?
So what would make the data change? Like what would trigger the change?
So for example, on this screen, a user logs in and something changes with your sessions.
Uh-huh.
So you need to refetch it.
You would have, in that case, if you log in a new user, you would have to recompose your trees anyway, I guess. So the use query that you have here, I guess you could pass it some keys that are going.
Key changes,
Yeah.
it composes, and it
Yeah.
refetches your data.
Exactly. This is how I would do it. Like it has to go through the composition tree anyway. And yet we also have like different fetch policies. So this is something I didn't show it here, but yeah, actually that's a very good call. Like it's just taking a query. We also have this Apollo call object. Have you used Apollo Kotlin before?
Yeah.
So we have the operations which defines your variables and everything. But we also have another object which we call Apollo call, where you can add some more options like fetch policy, like HTTP headers and stuff like this. So this use query is taking an operation, but we probably need one that takes an Apollo call with more options. So that's a very good point. So you can provide more options. And if you have like some more ideas like this, please feel free to open issues on Apollo Kotlin Compose, and we will make sure to add those APIs.
One final question is, so this is all still experimental, but are there ways that you say, well, that this is on the horizon, start building your user interface with already fragments, or is there a way to sort of have this architecture without these as an experimental macros?
Is the question, are we going to recommend everyone to use this one day? Or is it going to be stable one day? It's definitely going to be stable one day, for sure. Is this going to be the default? I don't know. Like, if you are... attending a few talks at this conference, look like this is the collocated fragment GraphQL conf, like everybody's talking about collocated fragments. So it feels like it should become the default, all right? But there is a lot of existing apps, and it won't happen overnight. So we are definitely going to support all the existing teams on the current schemes and architecture and everything. But yeah, in the coming months, it's depending on your feedback, very good feedback, we need to add more settings, so you can change the fetch policy, you can refresh, you can add more keys to use query. And this is going to be stable, yeah. Is it going to be the official recommendation? I don't know. Is it going to be the official recommendation?
Let's give users a choice.
Sounds good. Did that answer the question?
Yeah, we're now in the process of scaling up our GraphQL solution also for Android. So it's a bit soon now, but in general I like this this way of doing it.
Sounds good. Let's talk. All right. Thank you, everyone.